Welcome to my teaching channel again. This is the second video of data manipulation part 2. Before we start, make sure that you have this data file and the do file on your desktop. This time we are going to use a slightly different data file. It's called a GSS 2014 partial.dta. This is only a part of GSS 2014 data, so that it can be way much easier to locate the variable names that you are going to use. This data can be obtained from my Canvas channel. Double click on the SOC 5070 Stata 1 and 2.do to launch Stata. And then let's scroll down to row 363. In this video, we are going to talk about how to reverse the coding of variables. This skill is commonly used, particularly if you have lots of scale questions, most likely Likert scale questions. And some questions are asked in a positive manner, while others are asked in a negative manner. So before you can obtain a Likert scale score, you have to change those negative questions coding into positive coding, which means you should, for example, if you have a 5-point Likert scale, and that question is asked in a negative manner, so you have to reverse the coding 5 to be 1, 4 to be 2, and 3 is still 3. So that you can then go ahead to deal with adding up all the values together to generate a scale score. In order to achieve this, we can have various ways. And in this particular video, what I'm going to show you is a very easy and efficient way to deal with coding reverse. First of all, let's set up our working directory to be the desktop. Your path to desktop may be different from this one, so try to make sure that you change this directory to the one that pointing to your own desktop. So highlight row 369 and run. And in order to record everything we will do in the following steps, let's set up a new log file. So highlight row 378 and click on the do button. And then let's launch the data. Remember, this is now the full GSS 2014 data. It's only part of it. So it contains only several scale questions, so it's very easy for you to locate the variables that you need to use. So highlight row 382 and click on the do button. Okay, if you look at the data, it looks like we have only 13 variables. These are variables that we are going to use for this particular video. First of all, let's see how these variables are coded. Let's list frequency tables for variables CLS, ENOAM, CLSE, STAT, CLSE, TOWN, as well as CLSE, USA. These are 4 questions trying to measure people's feeling of closeness to various different objects. So let's highlight the row 390 until 400, and then let's run. You will see that in the output window, we have these 4 variables following the same coding scheme. 1 means very close, 2 means close, 3 means not very close, 4 means not close at all. You see that all of these 4 questions, how close do you feel to North America? how close do you feel to your state? How close do you feel to your town or city? As well as how close do you feel to America? All of these 4 questions are positively asked, while the coding scheme starting from 1 to be very close, while 4 means not close at all. This one is against our common sense. So how about we reverse the coding scheme? So the code 4 will be 1, 3 will be 2. Okay, and then let's reverse the coding scheme so that you will always have 4 meaning very close, 3 close, 2 not very close, and 1 not close at all. So in this way, I think your scale score could be more easy when you write your report up. Okay, so in order to achieve this task, we can use the skill that I introduced in the data cleaning and manipulation part 1. We can use recode. We can use recode followed by the variable name and this coding scheme that reverse the coding. 4 will be 1, 3 will be 2, 2 will be 3, and 1 will be 4. And then let's generate a new variable. And later on, we define a new value label where 1 means not close at all, 4 means very close, and another 2 values in the middle. And then we attach this value label to the new variable we generated from the recode command. Well, if you don't have so many variables to do this kind of reverse, I think this is a good way. For this particular case, all you need to do is to run the row 405 to generate a new variable, and then from row 408 to 410 you attach a new set of value labels to this newly generated variable, and then you repeat this process another 3 times, each time for a different variable. Okay, so how about we highlight row 405 and run. Let's see the result. Once you recode CLSENOAM, you will generate a new variable called CLSENOAM underscore R. Underscore R means this one is a coding reversed variable for the original variable CLSENOAM. And then let's define a new set of value labels and attach that new value label to the new variable CLSENOAM underscore R. So let's highlight row 408 to 410 and click on Do button. And if we tab the frequency table, we list a frequency table of CLSENOAM underscore R, we will see that this time the code of the original variable has been reversed. So 1 means not close at all, while 4 means very close. So you follow this idea and repeat this kind of operation to another 3 variables, one after another, then you finish the task. This way of doing coding reverse is okay only when you have a very limited number of variables. How about you have a study containing a dozen or dozens of scale questions that you need to do the coding reverse? This way could be very low in efficiency. So let's introduce a good or say more efficient way of getting this task done. So how about we delete the variable that we just recoded from CLSENOAM. Let's drop CLSENOAM underscore R. We no longer need it. In order to get this job done, we need to download a new command from the internet to your local Stata installation. So this new command is called revrs. This command was not shipped with your Stata installation locally, so you have to download it and install it to your Stata so that you can enjoy this new feature. In order to do so, we need to use the command find it followed by the new command name that you want to download. So on row 429, find it space revrs. So let's highlight row 429 and click on do. So there will be a viewer window open for you, and it looks like only one package was found from the internet with this given command name, revrs. So let's click on revrs from this link. Now we have the title of the command and a very brief description of what this command can achieve. So here, let's go ahead and click here to install. Click on this link. Wait a while until you see installation complete. Until you see this, that means this new command has already been installed to your Stata, to your local Stata. So now you can go ahead and close this viewer window. And to make sure that you have this new command properly installed, one way to double check it is to see the help file of this new command. So how about we highlight row 432 help revrs and see if we can open the help file of this new command. Okay, so it looks like we can open the help file of this new command, and it further confirms that we have already installed this command in our system. So let's go ahead and close this help revrs window. And let's test the power of this new command. This new command has a very simple syntax, revrs, followed by the variables that you want to reverse coding. So you can have a very long variable list. Each variable name will be separated from another variable name by at least one space. So if you want, you can have more than one space, it's okay. But you have to keep at least one space between two variable names. And this variable list can be very long. So let's try this new command and see its behavior. So how about we highlight row 435 and run. You see no particular output, but if you look at the variables list, it looks like there are 4 new variables, revclseNOAM until revclseusa. It looks like once you run this command without any warning or error, you will generate some new variables. Each new variable will start with rev followed by the original variable name. I think this is the default feature of this variable. So let's check if we really have the coding reversed. So let's list the coding for the original variable CLSENOAM, and then let's list the frequency table for the newly generated variable REV CLSENOAM, and let's see the difference. So in the output window, you see that the original coding one has 273 cases, and in the new variable, the original coding 1 has been transformed into coding 4. It has 273 cases. You can do this kind of double checking row by row, or you can do this task in a more efficient way. How about we list a cross tabulation of these two variables? If all cases fall into the diagonal cells, that means this coding transformation, this coding reverse is successful. So how about we highlight row 441, This one is now no longer frequency table because we have two variable names followed by the tab command. And this is actually tells Stata to list a cross tabulation of these two variables at the same time. So how about we highlight the row 441 and click on run. In the output window, we see that we have this one as our new variable, the coding reversed, and the column variable will be our original variable. It looks like all these frequencies focus only on the off-diagonal cells, and the original value 1 has been transformed into the new value 4. Original coding 2 is now the new coding 3. Original coding 3 is now the new coding 2. Finally, the original coding 4 is now the coding 1. So it's clear that this command achieved our task. And I think this one is a more efficient way if you have so many variables to do the coding reverse task. It's way much easier than use recode. Okay, I think that's everything that we want to cover today. So before you go, remember to save the log file by run the command on the row 446, and then clear the memory for by issue clear command on 454, and then you can exit Stata. See you next time.